So let us work on some problem for the time of flight and range when the projectile is projected from different locations, not only from the ground. First question is, find time of flight and range in following case. The projectile is projected from ground with speed 10 meter per second in this direction at an angle of projection 30 degree with horizontal. So we have taken y-axis here in this direction, x in this direction, and this is your horizon. So what will be the range? This will be the range, and the time of flight, you know that the time duration for which the particle or projectile is in the air. You already have the formula for flight of time, or time of flight, sorry, the time of flight when the projectile is projected from the ground and it strikes back to the ground. So during that period, the time which has been taken is your time of flight, and we write the formula for that as 2 into initial velocity in the y direction divided by g. So what is your uy naught? Your uy naught is uy naught is this, and your ux naught is this. So uy naught is 10 sine 30 degree. So your uy naught is equal to 10 sine 30 degree, which is 10 into 1 by 2 is 5 meter per second. Put the value over here, 2 into 5, and g we can, for the convenience of calculation, we can take it as 10 meter per second square. So this will be 1 second. The time of flight we got. Same way you know the formula for range in such case where the particle is projected from the ground and it comes back again to the ground. That is u square sine 2 theta by g, where theta is the angle of projection, that is 30 degree. And u is the velocity, initial velocity with which the projectile has been thrown. So you have already 10 meter per second. Sine 2 theta is sine 60 degree. Root 3 by 2. So put the value over here. 10 into 10 u square, this is root 3 by 2, and g 10. So range is 5 root 3 meter. Now next one, when the projectile is thrown from the top of a wall and the wall height is 20 meters and it has been thrown parallel to the ground. So, our y-axis will be like this, and the x-axis will be in this direction. This is your origin. So here the time of flight will not having the same formula as it was projected from the ground and the projectile is coming back to the ground because it has been thrown from a height. So it will remain in the air coming from here to here. So how will you get this time of flight? Let us say that again as capital T, the time of flight. So you know the formula h is equal to, in vertical direction, h is equal to uy naught into t minus half g t square. What is your uy naught? Particle's initial velocity is only in the direction of x, so it does not have any component in the y. So uy naught is 0. And what is h? H is in the negative direction of y, so it should be minus 20h. So you put the value over here. G, take it as 10. If t square is 20 into 2 by 10, so t is 2 seconds. So your time of flight is 2 seconds. And what about the range? During this time period, how much distance it traveled in the horizontal direction? Or what is the displacement of the particle in the horizontal direction? So simply you will get range as ux naught into t, because in the x direction there is no force, so the velocity will be constant. So it will be same throughout. Simply we will multiply it with time, we will get the displacement, that is your range. Ux naught is 10 meter per second. Time of flight we have already calculated, so range is your 20 meters.